Right, the goal of this problem is to express the limit as a definite integral on the given interval. And here we have these x star sub i's. So we know that x sub I, if you have say a graph, and we have an area under the curve going from A to B. We're trying to find the area under the curve going from A to B, and normally we draw these rectangles. In this case, it's these right side rectangles where you're hitting the graph on the right side of the rectangle, and you're getting your corresponding heights. So if this is x sub I, then this would be f of x, or if this is x sub 1, then this would be f of x sub 1. All right, and then the width of each rectangle, right here, will be delta x. And the distance from one rectangle to the other, so the next right endpoint of the next rectangle would be x sub 2, and this would be f of x sub 2. Now, let's say you have rectangles. Let's say you could pick a point. Okay, so these guys right here, these smart numbers right here would be xi values, not xi star values, xi values. And that's because they are either on the right side of the rectangle, or maybe you have some that are like on the left side of the rectangle or the midpoint. X star I, or xi star, just means it's any number that's in here that's not necessarily an endpoint of the rectangle. And the idea is that it doesn't really matter what that number is in here, because if these rectangles become infinitely small, then it's always going to hit the graph, right? So it doesn't matter if you're talking about like right hand endpoints or left hand endpoints or midpoints. If you're going infinitely small, then it's always just going to like correspond to a value that actually touches the graph. Okay. Or it's basically just going to touch the graph. Oh, so that's all that is. So it's called it says it here. So is a sample point. Let's see. In the ith subinterval. In the ith subinterval. X I minus 1, comma, x sub I. And all this means is just any interval, like that's like the left side of a rectangle, and that's like the right side of the rectangle, right? So that's just like here's one side, that'd be this side, and then the other side would be this side right here. And x sub I is just any value in there, not necessarily an endpoint value. All right, back to this problem. But for the sake of this problem, it really isn't super important. All we're trying to get is a integral from a to b, all right, of a function dx that is represented by that. Okay, well, this means like, sample point, but you don't have to worry about that because we're trying to get a general function. So you can just write it as your function is basically this, because the general formula is limit as n approaches infinity of the summation I equals 1 to n of f of x sub I star delta x. All right, and this just means, all right, we're going to put some smart numbers in here to get like cool values for our little rectangles, because this is going to be our, basically we're getting values within our interval. And this is the y value that corresponds to it. So this is the height of a rectangle. This is the base of a rectangle, right? So you get your height, you get your base, and together you get your area. But we're just doing it with, we're kind of making rectangles now out of not endpoints. These are non-endpoint values. So non-endpoint value, same thing as sample point. But for over here, they just want the general function. All right, so the general function is basically this piece right here, because it's this piece right here. And it's that piece right there without, instead of x sub I star, you're just going to put x. All right, so that means our function is f of x equals 5. Instead of x sub I star cubed, it's just 5x cubed minus 4x. Okay, that's our function. And we know we're going from 2 to 7. Great. So we're going to go from 2 to 7. And we have our 5x cubed minus 4x from right there. And we're going to go dx. I'll put that in parentheses. And that's it. There's your answer.